Hey YouTube, it's JP Dillon. Welcome to part 3 of the Fisher 450T solid state receiver repair. In the last video we took care of the problems with the power amplifier. The power amplifier is working happily again. And yes, for those of you wondering, I did catch the 4 microfarad capacitor that was not a 1 microfarad capacitor. So anyways, but we need to get to the preamp now. The preamp is the next main offender, which has a lot of DC at the output due to failed capacitors. The tonal response is okay, but really we need to get this thing top notch. And if we have time in this video, we'll address the phono stage 2. But in order to get to the preamp, you have to remove the front panel. And that's as easy as removing the knobs, and then you have lock nuts here that you need to remove, and then the faceplate will just pop off. So let's do that. And before you completely pull the faceplate free, make sure to disconnect the tuning meter. Otherwise you could end up breaking it. So undo your nuts. These just pull off. They are marked for polarity, so no big deal there. And then we can just take the faceplate away and set that aside. And then we also have to undo all these lock nuts here in order to get the preamp out. And make sure the bottom cover's off too, so you can see what you're doing. And with the bottom cover off, we see that we have more connections here along the side and ones over here as well. It's a good idea to make a little map and just disconnect all of these, because it's easier to remove this board and just pull it out than trying to wrestle it out of here with the push buttons and everything over here and other things. So undo your nuts, make a map of where your connections go, and then just pull everything out as one piece. You're also going to find it necessary to unsolder and remove the cover for the power switch, and unsolder the power switch too. And when you remove the back cover, this is what you're looking at. And you can see here that this is jumpered on this side. You have a white here, empty there, and then your two cloth at the bottom. So just note where those go, and then we can take the board out without any sort of impediments. Alright, so here it is with the board out. And I'm not going to lie to you, you're going to have to wrestle with this thing in order to get it out, because it is very tight behind the front panel and the tuner. So don't be surprised. You're going to have to very carefully angle it out in a way, do a little flexing without excessively harming the board. So here it is. Let me go over some things here. What you're really after are these gray ROE electrolytic capacitors. You'll see some other ones down here. I think these are tantalums. Very rare do they ever die, but it doesn't hurt to replace them, like this one down here. If it'll focus for me, it says 105, so that's a 1 microfarad, 35 volt. And then we have another 1 microfarad, another 4, one at 70. Now I've never understood why they have these 1 at 70s here, because the highest voltage in the set, I believe, yeah, the highest voltage the preamp gets is, I think, 35 or 36 volts. So anyway, so we can put a 1 at 100 in there, but just because. And then we've got more of these. Let's see if I can brighten this up a little bit so you can see it. But like there's a 0.33 at 35. And you can compare them on the schematic too. Now the other points of concern. The electrolytic capacitors are really feedback and bypass caps for the preamp. They don't really affect the tone at all. If you have tone issues, like you've got a sharp roll-off or something, what you're looking at are these couplet devices, PC202 and 201. These are your tone networks. And on occasion, you'll find one that's dead. It's got an internal component that's failed. So if you look at the schematic diagram, it tells you what's inside. So they're very nice about that. And so you can see what's inside of the couplet here. So if you have to reproduce it, you can. You can usually just use perf board or something to get it in there. It's not terribly complicated. And obviously you could pull this out and run some tests on it and kind of get an idea once you figure out which channel is responsible, what component is in there. And sometimes you can do a dirty bypass too. Like, if you ohmed out between pin 3 and 5 and there wasn't 22K there, you could add that and probably restore the tonal response. But that's a very lucky shot. Now, another thing that people want to tell me to do is, oh, you should replace the transistors. Well, yes, you could. The problem here is trying to find ones that don't oscillate in this circuit. You can try the KSC 1845s, but what I've learned from experiences is that if you go above about 250 beta, you start getting problems with gain and oscillations and distortion. There's not a whole lot of published information about these transistors, so it's really kind of a guessing game. I have used 2N, the infamous 2N2222, a little bit beefier device would be like a 2N5551. They're relatively low gain, around 100 megahertz. They kind of work. But yeah, they definitely, you can see them listing here, the tantalum ones and the regular electrolytics and all that. So because we didn't see any transistor noise in the actual preamp itself, I'm not really going to replace the transistors. They're working correctly. Their failure rate is almost 0 on these machines. So we're just going to go about recapping it really, and then cleaning the pots and things and kind of putting it back together. So let's get to that. Okay, so we got our little topology map here in case I forget where things go. And I have marked underneath here for quick desoldering where all these components go. They're marked in kind of a purplish blue here. And you do have to lift up those ceramic capacitors there in order to get to some of them. So let's get to desoldering them all. We'll yank them out and then we'll put new ones in. I find that by mapping everything and doing it this way, it takes far less time overall to remove and repopulate these boards. I also know some that'll just, well, they'll trust the board, which I'm not into doing. At the very least, you could take a high-resolution photo, because what I've learned is that the board is not always correct. And all manufacturers have been guilty of that. I've seen it on Sansui, Fisher, Pioneer, Marantz, Kenwood, Yamaha. They've all made their mistakes. And you find that if you follow the board, that you'll insert a component in incorrectly, flip the switch, and then it goes kablooey. But right now, I may have to go at that with an X-Acto too, because that one's really not wanting to come loose. Right now we're just going to focus on depopulating this board. And then we'll put the new caps in. Thankfully, this did not have any tone control problems, otherwise we'd be building it a couplet or attempting to work around to repair the existing one. And that's definitely tedious work. So I apologize to those who may have one of these that has a couplet problem, and I'm not walking through this, but that is not on my docket of things to do for this machine. Let me rotate this so I get a better angle of over here. And pretty much anything with these ROE capacitors, Fishers, Revox equipment, Telefunkens, whatever they're in, Grundigs, they're almost always bad. Now, I've never run into a bad tantalum on these boards yet, but I replaced them anyways because, well, the set's more than 50 years old. And even films these days of this age are starting to break down, so I don't leave stuff in like I used to. 10, 15 years ago it was a different story. So I'm going to see if these will come out nice and easy. It looks like they will, or at least this side will. The density of components here is a little high, so you may have to persuade it somewhat. And the way I usually do that is I just find where it's still holding on and lift it with an X-Acto knife. And in theory, it should come out, assuming the rivet isn't holding it in place, which this one still appears to be. Let's see if that does it for us. Yeah, much better. And then we'll just remove these guys. The hemostats make this so much easier in a tight spot. There's always going to be one or two that fight you. Move some stuff out the way so I don't completely destroy it. This one's got a rivet holding it on. That one's going to fight me, so let's remove some more solder. And let's see if we can get that end up that's still grabbing on. And let's see if she'll come out now. There we go. And then the one down here. That one, half the leg stayed behind. Oh, well, that's because I was an idiot and I didn't desolder that one. The fact that the leg on one side came up so easy suggests that it was going to let go soon. Alright, takes care of that guy. Okay, so that takes care of all the tantalums and electrolytics. And now we'll go ahead and get a new bunch of capacitors to replace these guys with, and we'll repopulate it. Okay, so we have 0.33s, which replace the tantalums, and we'll insert those first. And based on the map that I drew here, I'm going to put this down here first, bend the leads over so it doesn't go anywhere. And the next one is going to go up top here. Okay, then we have 1 microfarad tantalums, which go over here, C202, and 204. Bend the leads over. We got the one over here. Sorry if I keep shifting that off camera there. And this one I think is bumping into one of these. Yep, so you got to move that aside to push that through. And then the last, did I get that? Yeah, I did get that one. Okay, the last low voltage one is going to go in here. Now, it's very difficult to get 1 microfarad at 70 volts or 80 volts, so we're just going to use the 100 volt versions I have. And those guys just go in here. And in here. And then the other one goes up here. And then finally the one adjacent, which goes over here. Okay. So now those are all in there. And I see that one of the little sticky backed fish paper things has come apart. We're going to reattach that. It's important to have that there so that components don't short out against the chassis or against the PCB. So we're just going to solder these guys in. Doesn't take very long. Now imagine trying to struggle with this while it's still attached to all those short little wires. You just gotta pull the board out. I've seen people who will like cut and resplice it rather than just unplug it, or they'll like try to finagle getting parts in and out of there while it's dangling from the wires. On some machines you kind of have to, but they usually provide enough service slack where you can do that. But on this one, you gotta pull the board out. You just have to do that, no shortcut. But once you do, it makes it just so much easier. When we get to the phono stage, it'll be kind of the same thing. So I'm just going to clip all these leads off. Oh, there's some I didn't solder yet. I think somebody asked me in another video, like, how hot do you run your iron? Well, on this particular application, I'm using about 800 degrees Fahrenheit. Highest I run is 850. Let's push this back down. And we'll turn the rest of these guys up. And then this needs a little tiny blob of glue, because obviously the double-sided adhesive is not there anymore, but we really only need to attach it to the capacitor, and the capacitor is just going to hold it there. So that won't take long to dry. And so there's the board. This is a good time to spritz some contact cleaner in, some CRC or fader lube, either one. Work the pots. So there's our nice fancy board all repopulated. We'll get it back in the machine, and then we'll test it and see if the preamp works correctly. Okay, so let's see if our fancily recapped preamp is going to do us any good here. There we go. Nice clean sine wave. Let's see if it's fairly up. We got non-linear response there. That's probably due to the touchy ass. Let's see. Do we have a filter? Oh, helps if I actually turn the tone controls into the right spot, huh? I need to clean those again. Alright, let's try our linear frequency response test. I can see that the channels are a little bit nonlinear at that volume spot. Amplitude doesn't change all that much, which is really good. It's got our starts to attenuate a little bit after 40 kilohertz, but that's to be expected. And then if we get down in here, yeah, below 20 hertz you don't get much. Get a lot of distortion there on that waveform. 20 hertz still looks pretty good. It's hard to see because of the frame rate in the camera, but it's very linear, so that means that we did good as far as a recap. We don't have to mess with any of the couplets. I do need to clean all the pots and switches again. When the CRC doesn't cut it as well, you dig into the fader loop. But anyways, we're good there. So the next step is getting the phono preamp out. And that there next to our little selector switch is our cute little phono preamp. Let's see, just for grins and giggles, if putting a signal through it shows that it kind of sort of works. Because I really don't want to have to troubleshoot these couplets if I don't have to, since that takes an enormous amount of time. Okay, so with phono selected, let's center the balance here. We've got a pretty linear RIAA curve there. More bass, less treble. That's what it's supposed to be. Got a little bit of phase shift there. If we put them on top of each other, you can see it. And that's going to change as we go up and down in frequency. So a little bit of phase shift there, probably due to dying caps. No real surprises there. Pretty much just what I'd expect. So let's yank that board out and get to recapping it. And again, it's just a matter of making a map where the wires go, yanking them and pulling them out. Not too tricky there. Okie dokie, there's our little diagram. Okay, well, out she comes. And there's not a whole lot to this one. You've got some itty-bitty capacitors up there. And it's hard to tell who came first. Probably this guy. These are the same value, these 500 microfarad ones, but one is made by a different manufacturer. And then we've got these ones down here. Focus, you idiot. God. Alright. 0.5? Is that what that is? 0.47. Yeah. Let's look and see what the schematic diagram says. Yeah, it definitely looks like C104 and C103 are supposed to be 0.47 microfarad. And 107 and 108 are supposed to be 4 microfarad. The little tiny black guys at the output there, which is weird, because these tiny little things here, these black guys, are the 4 microfarad, but the big tall ones here at the back are the 0.47 or 0.5 or whatever it is. So I guess it's just different construction, because you'd expect the opposite. Like the 4 microfarad would be big, but the 0.5 would be small. Well, it's also at a higher voltage, so I suppose that's true. Oh yeah, another weird note. So you're looking at this thing here that says separation control. So they actually use this amplifier as part of the output of the multiplex. So you see the separation control, it does not affect the phono stage. It affects only the FM multiplex. A couple of people did that at this time period. So you'll see it on Sansui machines, you'll see it on Pioneer machines of the same late 60s vintage. Maybe Kenwood did it too. But yeah, the separation control, that's for your multiplex alignment, which, assuming we do the tuner, we'll get into that later. But in any case, yeah, so that's your phono preamp there. Let's depopulate it and recap it. Alright, so here's our circuit board. You can see I've marked the capacitors to remove the little red stripe across the terminals. I have my little map layout so I know what goes where and what the polarity is, with the exception of the 4 microfarad, which may be non-polar, but I have those, so I'm not too worried about that. So let's just go ahead and desolder these guys and get them out of here. Then we'll worry about repopulating it, popping it back in, and hopefully everything will be happy with it. Then we can start focusing on the radio portion, which is non-functional at this moment. And once we get all the disabling failures fixed, then we'll focus on redoing the power supply. Because right now the power supply is working, and because it is working, I'm using it to help me troubleshoot the parts of the machine that are not. So I know everyone gets this idea about blanket recapping, and when you get machines of a certain age, that's a good idea. So if we were looking at very early solid state, like 1962 or 63, then I would want to do a blanket recap before I started troubleshooting, because oftentimes leaky capacitors between stages would excessively bias fragile transistors and blow them out. Not a good idea. But this one, being that it's a later design with silicon transistors, yeah, that can, you know, there are modern replacements so that if I screw up, I can usually fix the problem. But this older germanium stuff, although yes, you can get Russian counterparts, it takes a lot of time to figure out what's going to go in the circuit, and trial and error in making it work. So you could be spending an hour to replace one transistor simply because you haven't found the one that works in the circuit yet. So just, yeah. But with this one, since the power supply is working and there were many systems that needed help, the biggest being the amplifier on this job, I wanted to take care of those first. So that's my reasoning behind that. I hope that's, you know, clearer than mud. Okay, just making sure we don't have any disagreements with polarity. Okay, so the board is marked here, and they do have a tiny little plus symbol for the 4 microfarad there. These caps are almost always bad. And we'll take these out. So, alright, so now we're depopulated. Let's get our replacement capacitors. Okay, so now we have our replacement capacitors here. And here's our 470, which we're using in place of the 500, and it's not going to care. The circuit does not care about that. Trying to find a 500 microfarad capacitor at the voltage we're looking at in a radial style like this is going to be very difficult, if not expensive. Alright, so the next thing, we've got the 4.7s. And I'm going to slide those in there, fold the leads over, And I'm obviously not setting it down because it's just going to push the capacitors out of where I just put them into. The 0.47s. All right. Let's just go ahead and solder all these guys in here. Then we'll put the board back in and see how well it works. And again, most of these electrolytic capacitors are entirely for interstage coupling and decoupling. So if we had a slight phase error before, that's probably the fault of the couplet. And it's not enough that warrants a complete teardown. If it had, like, maybe a 15-degree shift or something huge, I would say, yeah, it probably needs to get taken apart and fixed. But a couple degrees of phase shift really is not going to be any noticeable audible symptom in anywhere but a perfect room. Trim all the leads off. Okie dokie. That's happy. And so now we'll reinstall it in the set and see how well it works. Okie dokie. So it's all wired back in. Let's see if it works. Okie dokie. All powered up. And we do have a little bit of cellular interference. And let's see here. Still got good curve response. Do we still have our phase shift? No. We do have a little bit of jumpiness there. Let's see, is that a... Oh, we have AM, still no FM. That selector switch is touchy. Okay, so we have a little bit of bobble in that one channel there. What I need to do is listen to that and make sure that it's not just cellular noise. So the bobble we're hearing is in fact cellular noise. You can kind of hear it in the speaker. Alright, so I'm not going to worry about that. What's even more interesting is now that I reorient the machine, you can see that it's moved to the left channel. The left channel bobbles now. So if I rotate the machine more, we see that it's quiet. So that's the wonderful cell tower out front. Well, anyways, so that takes care of the preamp and the phono stage, which is good. So now all that's left is to figure out why our FM doesn't work. That'll be for another episode. So anyways, hope you guys enjoyed this one. More stuff to come.